Continuing on with Chapter 20, starting on page 570. So biofuels, we just spoke in the last video about E85. So we don't really see these in Santa Clarita, although I think there is one gas station up near Castaic that has E85 in it. But we don't really see these because we don't use them here, but in the Midwest they do. So they have vehicles that can run on E85, a flex fuel vehicle. One of the other issues that we have with ethanol is that we don't grow enough corn to currently replace all the gasoline in the US. So this is the amount of corn that's grown today. This is what would be needed if we were going to replace gasoline with ethanol. And we don't have that much land available for growing that much corn. That is our food supply. So this is not a good solution to energy issues. Okay, the next kind of biofuel is biodiesel, and biodiesel can be made from used cooking oil, and which they can get from restaurants, and it's less emissions, it's non-toxic, it's biodegradable, and I've heard that your car smells like French fries when you drive it down the road. And at the top of this page at Loyola University Chicago, you can see that they have a truck made from biodiesel. You can actually buy a conversion kit. I've known of people, not personally, but heard of them and seen little videos of them where they've turned their car into a biodiesel car with a conversion kit, and then they know somebody who owns a restaurant, and that restaurant person donates their used cooking oil from like the fryers, from frying chicken or French fries, to them. Or you can buy biodiesel too. So if you don't have anybody that donates it, there are companies that will sell you biodiesel. So algae is being experimented with. It was actually on an FRQ a few years ago about a potential source of biofuel. The good thing about algae is that it also, growing it, absorbs CO2 out of the atmosphere to combat climate change. So it's a win-win. So we can grow it to create a fuel out of it for our cars, and at the same time we're growing it, we remove the CO2 from the air. So it's kind of a good thing, and I hope that they are able to use it. So again, they're experimenting with it a lot. Right now it's very expensive, so they have to get the cost down in order to make it cost effective for consumers to use on a regular basis. Okay, moving on to hydroelectric power on page 5. You know what, actually page 574, let me just talk to you here. If you could just put a little sticky note here, and I'm going to add one later, about switchgrass. Switchgrass is one that's being studied quite a lot for biofuels because it grows really quickly. It doesn't take much pesticides and fertilizers, and it's a really good crop that is actually better for the environment than corn for creating ethanol out of. Switchgrass is. Okay, going on to hydroelectric power. So we have this graphic here showing you how a hydroelectric dam works. So we studied already the pros and cons of building dams as reservoirs for drinking water, but now it shows you one of the benefits of a hydroelectric dam in that it provides electricity. So the good thing about this electricity is that once the dam is built and paid off, and on most of our dams in the United States were built so long ago, they've already been paid for, and so basically this is now cheap electricity. It's the cheapest electricity we have in the U.S. because we don't have to burn anything, we don't have to dig anything out of the ground, we don't have to grow anything. All we have to do is just let water through turbines, and so all we have is really upkeep. And so it's very, very cheap energy. Okay, so basically we force water through, and the force of the water spins the turbines and then creates spark in a generator, which we then send to homes. And the turbines are actually really huge. You can see those here. So the good thing about hydroelectric dams is there's no greenhouse gas emissions and there's no air pollution, so that's a good part. Another type that we don't see in California, or at least in Southern California, because we don't really have very many running rivers, but let's say you own a piece of property by a stream or a river. you can actually have some of that water go through pipes, and then it increases. The way that you engineer this is that it will start speeding up and going very quickly. And then the pressure, you can have your own little mini turbine in here and generate just enough power for your house. So that's pretty cool if you live by a river and you can do that. So hydroelectric, the good parts is that it has no air pollution nor any greenhouse gas emissions. The problem with hydroelectric is that we can't expand in the U.S., so even though it has these really good things in terms of air pollution and greenhouse gases, there's no more really available sites to dam. We've dammed everything we can pretty much dam decades ago in the U.S. In tropical countries, however, they are still creating dams because they haven't been as industrialized as us. But in tropical countries, one of the problems with dams is it can breed mosquitoes, which cause more malaria, yellow fever, and nowadays Zika as well. One of the good things about hydroelectric, it's cheap per megawatt of power. But you do need to know that new dams like Three Gorges release methane due to the decomposition of flooded plants behind the dam in anaerobic conditions. So we've already studied that as well. All right, that's the end for chapter 20.